Greetings, my name is Mrs. LAZARUS and my group member is WONG, PENG, MELING, Darrell, Esmund and MOHD KHAIRULFADZLEE, and we will be presenting our assignment about vapor absorption system for ship air conditioning system. Now this is the content of our presentation, which is introduction on vapor absorption system, introduction on heat system, estimated amount of heat could be used for the vapor absorption system, schematic sketching on proposed ship vapor absorption system. Moving on to the first slide, which is introduction on the vapor absorption system. Michael Faraday made the groundbreaking finding that led to the formation of the vapor absorption principle in his attempts to liquefy different gases in 1804. And in 1860, French scientist Ferdinand Care developed the first refrigeration system that utilized the vapor absorption method. And then, regardless of the size of the unit, this technology may be used in both residential and commercial refrigeration system. The most common refrigerant in vapor absorption system is ammonia, which is used as a refrigerant agent. And rather of using mechanical energy, the vapor absorption system uses heat energy to modify the refrigerant properties in a manner that is essential to the performance of the refrigeration system. And next is compressor in vapor compression system are responsible for extracting the evaporator's vapor refrigerant. And then condenser are able to effectively reject heat from higher pressure vapors, and the compressor is replaced by an absorber, pump, generator and pressure reduction value in the vapor absorption system. Refrigerant vapor is put into an absorber where it's absorbed by the weak solution of refrigerant, creating a stronger solution. In the generator, the highly concentrated solution is poured in and heated by an external source. To achieve a liquefied refrigerant, heat is applied to the solution in order to force out the gaseous refrigerant, which is then drawn into the condenser and condensed. Then afterwards, the liquid refrigerant is delivered to the evaporator, bringing an end to the cycle. That's all from me, and I'll pass on the next slide to the next presenter. Thank you.
Thank you, Mr. Slam, for the presentation. Now I'll continue. My name is Ong from Bmmv S2/1. I'm here to present introduction on ship system focused on system that produce heat. As seen on the slide, Figure 1 shows the heat balance for large bore engine types with and without WHRS, and Figure 2 shows the waste heat recovery system for the flow. So I'm going to present about the waste heat recovery system on board, which is WHRS. A waste heat recovery system, WHRS, is a system that uses waste heat from ship engine to create electricity. A WHRS transfers heat from sources such as hot output gases or steam to other engine operation to save energy and improve the energy efficiency of the ship's engine. Many waste have technology solutions are available for industrial applications. In-depth analysis of the most applicable options for ship engines, along with a complete description of these technologies. The Rankine cycle, RC, is a thermodynamic cycle that transforms thermal energy to labor. The Kalina cycle, KC, is a thermodynamic power cycle based on a combination of ammonia and water, an exhaust gas turbine system, and a thermoelectric generating system. So, the present work utilizes a steam turbine, power turbine, which is ST to PT, combination system that combines energy recovery with an exhaust gas driven PT and an ST to create energy. This integrated system offers a greater possibility for recovery than the other standard WHRS options. The principal cause of high temperature in shipping is the high heat flow and temperature of ship's primary engine exhaust gas. According to study of MELING WHRS, it is possible to generate up to 11% of primary engine electricity power for exhaust gas. So hence reducing the primary engine fuel consumption to between 3 to 8%. The energy efficiency of ship's main engine around 50%, and this efficiency results low consumption for the oil, and also especially for fuel oil consumption depends on the engine's loss factor. So that's all from me. Now I'll pass it to other person. Thank you.
Hello, my name is Justin MELING and GALAU. Today I'm going to present about estimated amount of heat could be used for the vapor absorption system. First one is steam fire chiller with a single effect. Steam pressure required is 0 to 3.5 bar and energy source is low steam pressure. Next is chiller that run on steam. Steam pressure required is 0.1 kg per centimeter square to 26 kg per centimeter square, and energy source is saturated steam. Next is high pressure hot water. Temperature of hot water needed is 150 degrees Celsius to 180 degrees Celsius, and energy source is hot water. Lastly is chiller fueled by exhaust. Steam pressure required is 10 to 25 bar and energy source is exhaust gas. That's all from me. Thank you.
Hello, my name is Darrell Esmund, and now I'm gonna explain about the schematic diagram that we have come up with. So from the diagram, there are a few components that we have insert, which is the generator, condenser, evaporator, and absorber. In the diagram, there are a few labels, which is the QA, the heat added or supply, and the QR, which is the heat rejected to the coolant. Now for the working principle. So the water is employed as absorbent and ammonia as a refrigerant. Absorber mix the evaporator's vapors. The absorber's heat is rejected to flowing cold water via a heat exchanger deep in the absorber solution. Then next, the absorber strong aqua ammonia solution is pumped to the condenser pressure and delivered in the generator, which is the system major energy consumer. Generate heat, and the boiling point of the refrigerant NH3 is lower than that of the absorbing liquid H2O. Consequently, the vapors exiting the generator are largely those of refrigerant. Then next, the vapors are condensed. The condenser liquid refrigerant goes via an expansion valve or throttle valve to the evaporator, where it absorbs heat from object to be cooled. Evaporator liquid refrigerants enter the absorber to complete the cycle. The weak aqua ammonia solution in the generator is discharged to the absorber to repeat the cycle. The weak aqua ammonia solution exit the generator at high pressure, while the pressure in the absorber is the evaporator pressure, which is less than the generator or condenser pressure. And lastly, the generator and pump demand more energy than the vapor compression compressor. Since the pump handles too little liquid, its power needs are minimal compared to the generator. So that's all from me. Thank you.
Hello, I'm Muhammad KHAIRULFADZLEE bin Ali. For the conclusion, vapor absorption system is a system that uses heat energy to improve the performance of the refrigeration cycle. The process of the system is compression, condensation, expansion, and evaporation. Other than that, in a ship, waste heat recovery system or WHRS is implemented. The system is used to recover excess heat to create electricity and transfer heat from sources to other engine operation. This is to save energy and improve the energy efficiency of the ship's engine. Furthermore, heat can be used for the vapor absorption system. In the vapor absorption system, there is a machine that is used to produce chilled water using a heat source such as steam, hot water, natural gas or fuel gas, that is vapor absorption machine or vapor absorption chiller. In this report, there are three types of vapor absorption chiller, that is single effect, double effect, and direct fired absorption chillers. Finally, in this report, we have proposed a schematic sketching of a vapor absorption system that is suitable for our ship. With this schematic, we also attach the system working principle. That's all from me, thank you.